So we've talked a lot about in the last few hours of class about measurement, the purposes of measurement. Remember, we talked about communication, repeatability, keeping records so that you build something and a year from now you want to build it, you can make it the same size again. We also did a little demonstration where we measured a piece of paper with our pens here, and we came up, measured it with one, it was a little bit more than 2 pens long, and with the other, it was not quite 2 pens long. And the problem was that you can see the one pen is a little bit longer than the other. So to make measurement work, we had to have both people that were part of that communication had to have that object, and it had to be pretty close to the same size. Well, what they started to use for length measurement, at least, and that's what we're going to start out today, what they used was parts of the body. So the smallest unit of measurement we have that we use is the inch. The inch was the distance from the tip of the thumb to the point of that first knuckle. So if I were measuring this piece of paper with my thumb, I'd go 1, 2, 3, 4, and count on up to get the size of it. By the way, that motion you saw where I'm rocking my thumb, kind of rolling my thumb from the joint to the tip to measure, that motion is where the inchworm got its name, because it kind of moves with that same motion. So that's where the inch came from, the size of the thumb. What's the next unit we have up from the inch, next larger unit from the inch that we commonly use? Don't be shy, someone yell it out.
What?
A foot, perfect. How many inches are in a foot?
12.
12 inches in a foot, perfect.
By the way, we moved from 162 into 165.
Okay, so they're not going to boot up 162 anymore?
No, because it kind of sounds like gunshots. Something's wrong with the speaker.
It's a feedback loop with the microphone and the speaker. I don't know if the feedback cancellation got shut off or if there's a second microphone that's turned on. But yeah, it's a feedback loop is what it is.
Okay.
So we do have you all in there at least. That's what matters. Okay, so the foot is exactly what you'd think it would be. It's the distance from the back of your heel to the tip of your longest toe. Now, the foot, there's other units between an inch and a foot that are no longer necessary. For example, if I wanted to measure the height of this wall next to me here, I'm not going to dig in with my hands and go with my thumbs like that to measure it. That'd take way too long. We would measure it today with feet. But traditionally, if I was going to measure that with my foot, I could maybe get up to here with some serious stretching. But I'm not getting all the way to the ceiling unless I chop my foot off at the ankle. It just isn't going to happen. So the foot was used to measure things along the ground because that's where feet are. And that's where we can get to them with our feet. Things that were vertical like that, we couldn't use a foot for if we actually had to get our foot up there. So they had a unit called the hand. The hand was the width of your hand where the fingers meet the palm. That's about 4 inches is the conversion for it. We don't typically use it anymore, and I'll explain why we don't use that in a minute. It is still used in like livestock. Cows, horses, sheep, things like that are still measured in hands, or it's still the lingo at least that's used for them. The reason we don't use them anymore is in the 500s, King Edward declared that his thumb and his hand and his foot were going to be the official measurements of the land. Everybody was going to use his body parts for those measurements. So rather than having to take their own thumbs and use them, the craftsmen came in, they marked off a piece of wood the size of King Edward's hand, they cut those blocks and they passed them out for people to use, the same with his foot and everything else. So we now had this standard object, a measuring device. So now I didn't have to get my foot all the way up the wall. I could take my foot stick and go up the wall to measure it. So now those other units like the hand were no longer necessary. Going up from the foot, what's the next longest unit we use?
Yard.
A yard, very good. How many feet are in a yard?
3.
3. A lot of people think of a yard as being the length of your stride if you take a long step. And it is about a yard, but that's not where it came from. It's actually a tailor's unit. It's from the center of your chest or the tip of your nose to the end of your outstretched arm. If you ever watched an old tailor, they'll grab their fabric, they'll pull out, they go 1, 2, they're counting out yards. Now, of course, King Edward declared that his arm was the official yard, and they worked through that as well. There were some other units in there. One that's kind of important to you guys is the cubit. Have anybody ever heard of a cubit before? The story of Noah, the cubit came up a lot in the building of the ark. The cubit was a construction unit. It was the length from the tip of your longest finger to the point of your elbow. Now, humans are a lot larger now than they were at that time, but the cubit used to be about 16 inches long. And of course, in your field, everything is spaced 16 inches apart. With floor trusses and stuff, some things have gone to 2 feet, but traditionally, floor joists were 16 inches apart. Wall studs were 16 inches apart. Roof rafters were 16 inches apart. Roof joists were 16 inches apart. Everything was 16 inches apart. So they just used their arm to lay it in there and space it. It makes sense. They didn't want to have to get their foot up there and do 1 1/3 feet or count out their thumbs. They had that object, that cubit, their hand, that was the perfect size to space that out. Well, once they developed, the standardized units with King Edward, they created rulers. They started taking longer sticks and marking off where the end of each of the units were so they could use that for measuring it out rather than having to stick their hand in there or count inches or whatever. So the cubit wasn't necessary anymore. Larger than the yard, there were other units that we don't use anymore. One was a fathom. A fathom is approximately 6 feet. It was used for navigation for boats. A fathom was the depth of water that most of your major vessels could get, the minimum depth that they could get through without hitting bottom. The way they measured that, they literally would take one of their taller sailors, throw them overboard, and if their head stuck up out of the water, it was too shallow to go through. Hopefully they pulled them back in later, but who knows? It was different times. Again, with other measuring devices, the fathom was no longer necessary anymore. The furlong was in there. Furlong is 1/8 of a mile. That was the distance that an average horse could run with a rider at full speed before it had to rest. There is one in there that we're going to use that's a little lesser known called the rod. A rod is 5.5 or 5.5 yards or 16.5 or 16.5 feet. The rod was actually originally a shepherd's tool. A shepherd had the rod and a staff. The staff was that hook, kind of like Little Bo Peep has. They'd use it to hook the sheep around the neck so they could shear the wool or tend to any medical needs. It was a detention device. The rod was a defensive tool. They would take a sapling tree, cut it down, strip off the branches, and that's what they would use to fight off any wild animals that threatened the herd. So it was a pretty big stick, basically, is what it was. So how did it become used for measuring? Well, pretend I can draw and that these actually look like sheep. I'm going to pick on Isaac here for a while. Let's say Isaac has some sheep and I have some sheep and they're pastured down in a valley. And at the end of the day, I say that I have 12 sheep down there and Isaac says he has 15 sheep down there. And we look down in the valley and there's only 20 sheep. Well, one or probably both of us are lying about how many sheep we had. And a lot of fights broke out because of that. With cattle and horses, they settled that through branding. They literally burnt their insignia on the side of the animal so you could see quickly whose it was. With sheep, that didn't work very well for a few reasons. One, their skin wasn't thick enough to really to hold a brand well without doing any permanent damage. Two, their wool grew out so thick that you couldn't see the brand without pulling the wool back anyway, so it wasn't really useful that way. And three, and I don't know why I find this one so amusing, but I do. I guess I'm a little twisted. Wool is kind of flammable. Sorry, I'm just seeing the sheep go poof. But anyway, they didn't have a way, ear tags didn't exist quite yet at that time. They didn't have a good way of identifying whose was whose. So what Isaac and I would do is we'd find a landmark. Let's say we find a big rock somewhere. And we divided up the land. We said, okay, I'm going to pasture my sheep over here. Isaac's going to pasture his sheep over here. And if one of us complained, well, I think you got a bigger pasture than mine, well, we would start at that rock, and I would put my rod down on the ground. That's 1. We'd put Isaac's down. That's 2. And we just keep flipping them over and over and count. So it's 40 rods this way and 70 rods this way. So we know we have the same size land. To this day, if you look at the official survey for pieces of land, most of those surveys are done in rods. The other units that might be used is a chain. A chain is 4 rods or 66 feet. Those are the units that most land surveying is done in. Longer than a rod, like we said, we have furlongs and stuff like that, but we're going to skip up to the mile. A mile, of course, most of us know that to be 5,280 feet or 1,760 yards. Or if you really want to get out there, 320 rods. There's a lot of rumors as to where the mile comes from. The one that I find is the most credible is it comes from the Roman military. The rod, a mile, a mil in Greek is 1,000. If you look at your property taxes, they have a mill rate of 21. Typically, mill rates between 20 and 23. A mill rate of 21 means you pay $21 for every $1,000 of value. It's per 1,000. So a mile was the distance that a Roman soldier would march 1,000 paces while marching in formation. A pace was starting on your left foot, going to your right foot, and then back to your left foot. And that makes sense. About 5.28 feet per pace. 1,000 paces would be 5,280 feet. So the bigger thing is, how do we get back and forth from one unit to another? Well, if I have, let's say, 4 feet, and I want to convert that to inches. Well, most of you can probably just tell me that that's how many inches?
48.
48. Many of us have worked with feet and inches enough that we can do that conversion in our head. We just know, multiply by 12, you've got the inches from the feet. But if you didn't know that, the process you would go through to convert that is you'd start with the 4 feet, and we would make that into a fraction by putting it over 1. Now, you might be wondering, how do we make something easy by making a fraction? Fractions are a pain. Well, we're going to use that powerful tool that we talked about, the unity fraction, where the numerator and the denominator have the same value. Only it's not going to look the same. It's going to be the same value, but we're going to make it look, they're each going to look different. So we have feet on top here, and we're trying to get rid of feet. So to get rid of them, we're going to put feet on bottom here. So they're going to cross-cancel out in our calculation. We're going to inches, so we're going to put inches on top. Now the relationship, the equivalency between feet and inches is 1 foot is 12 inches. So the feet cancel out. Now we multiply. 4 times 12 inches is 48 inches. On bottom, 1 times 1 is just 1, so 48 inches over 1 is just 48 inches. Now, we don't really need the conversion factor for that one. As we said, most of you have done the conversion from feet to inches enough that you don't need to use that equivalency in that unity fraction. But let's look at one that you probably haven't done very often. Let's say I want to convert 99 feet into rods. Most of us can't do that one off the top of our head. But we can go through the process. 99 feet, we'll put it over 1 to make it a fraction. Now, once again, we're getting rid of feet, so we're going to put it on bottom so that they're going to cross-cancel. We're changing it to rods, so rods are going to go on top. Now, we look at our equivalencies. We know that 1 rod is 16.5 or 16.5 feet. So now the feet do cancel out. We multiply. 99 times 1 rod is 99 rods on top. On bottom, we have 1 times 16.5 is 16.5. And now we divide it out. 99 rods divided by 16.5 is 6 rods. Any questions? Well, the standard measuring system which is the units we just went over, is what we refer to as an evolved system. By evolved, we don't mean that it's superior or great or anything like that. We mean that it served a need, and eventually over time we changed it and adjusted it to make it work for a system of measurement. So like we said, inches, feet, and stuff all had their own different use. It wasn't until, first of all, King Edward set it in place by standardizing it using his thumb and foot and everything. It wasn't until a couple hundred years later that there actually was a conversion between units. There were not 12 of King Edward's inches in his foot. It wasn't exact. So they adjusted those units after a couple hundred years to make 12 inches fit in the foot and to make 3 feet fit in a yard and so on. So up until that point, if one of you measured something in inches and I measured another object in feet, there was no way of telling which one was longer or comparing them at all, unless we went back and remeasured one of them in the other unit. So they had to do all those adjustments. And so it evolved over time. It was changed as the needs changed, or we realized that there was a better way of doing things. Because of that, we have those awkward conversions, the 12 inches in a foot, 3 feet in a yard, 16 and a half feet in a rod. Things don't seem to fit together because they weren't created to fit together. We forced them to fit together later. Well, brings us to the metric system. In the late 1800s, around in the 1880s, so the metric system's been around for a little over 130 years at this point. Some people got together and decided there had to be a better way of doing measurement. At that point, we'd been using the standard system literally for thousands of years in some form or another. And so they knew what worked well in the standard system and what was really tedious and cumbersome in the standard system. So they decided to create a system. The metric system is a created system. And it was created knowing those problems in the standard system. It was created to get rid of those problems. So in the metric system, for length, they only had one unit of length. What was that unit? Or what is that unit? Not everybody at once.
Kilometers?
You have part of it there. The meter is what it is. Now the meter, I'm not in my classroom, so I don't have my meter stick behind me to show you. A meter is about 39.37 inches. A little bit longer. A yard is 36 inches, so it's a little bit longer than a yard. I always thought this was kind of silly, that it would have made life so much easier if they had just made the meter equal a yard. Well, remember I talked about King Edward saying his arm and his thumb and everything were the official units of measurement? Well, King Edward didn't rule the whole world. He ruled a part of Western Europe. In other regions, there were other rulers that made the same declaration. Their thumb and their foot was going to be the official units. So from one region to another, that standard measuring system was anything but standard. In fact, there were areas where they had 11 inches in a foot, or one where they had 14 inches in a foot. The conversion factors were very different, and the size of the units were very different. Well, the metric system was developed in Switzerland. And the meter is actually equivalent to the Swiss yard. So the Swiss yard was a little bit bigger than the U.S. yard. Well, you might say, well, that's silly. Why didn't they use the U.S. yard? We're, the dominant country in the world, or we have been for quite a while. Well, you got to remember, this is the 1880s. The United States did not really become a world power until World War I in the late 19 teens. Right before 1920, in other words. In the 1880s, nobody else in the world cared about America at all, about the U.S. at all. So the U.S. yard was not a concern. They used the Swiss yard. Well, so the meter was the basis of their unit of length, abbreviated with just a small m. If they wanted to measure something smaller, significantly smaller, or significantly larger than a meter, they used prefixes. The prefix deci meant 1/10. So dm was the abbreviation for a decimeter. That's a tenth of a meter. Centi. We talked about cent and percent. Cent is 100. Centi is 1/100. So cm was a centimeter, 100th of a centimeter, or a 100th of a meter. Milli, we talked about mill meaning 1,000. Milli is 1,000th. mm is millimeter. That's 1,000th of a meter. Now, they didn't do every power of 10 after that. They skipped the 10,000 and 100,000, and they went to the millionth. To abbreviate this is the prefix is micro. But since mm is already used for millimeter, they can't use that again for micro. So they use the Greek letter mu. We use that a lot in math when we run out of Arabic letters, or our standard letters to use. We use the letter mu. So mu m is micrometer. Then if you kept going, we skipped 10 million and 100 million. They went to the billionth. Might be able to squeeze 9 zeros in there. That was nano. Used to hear a lot about nanometers in nanoscience, and it's still out there. It's just not a hot topic anymore, but we're still working towards it in a lot of industries and using it. All that's talking about is working with things that are really, really small. A nanometer is about the size of an atom. You guys probably won't encounter that much in your careers. Wood doesn't really get measured down to that. A micrometer is probably something, in machining and metalworking you would see it, but not in woods for the most part. If we need to go larger, we had deca. Deca means 10. Now dm was deci, so they used dam for decameter. That's 10 meters. Hecto was 100. So HM was a hectometer, or 100 meters. And here's the one you mentioned earlier. Kilo is 1,000. So km is a kilometer, or kilometer. It's 1,000 meters. Now, once again, they didn't do 10,000 and 100,000. They skipped up to a million, which was mega. Notice I used a capital M on megameters because when we abbreviate mega, we use a capital M. Capital M, little m is a megameter, or a million meters. Now, the circumference of the Earth is only 25 megameters. So it's really too big of a unit to really be useful. The only place the mega prefix is really used in electronics. You talk about your computers, you have kilobytes, megabytes, gigabytes, terabytes. Those are all metric prefixes. Obviously, a gigameter is really not useful at all because it's 0.025 gigameters is the circumference of the Earth. It's just too big to be useful. And realistically, in practice, what gets used is the main unit, in this case meters for length, the thousands or the kilo, and the thousandth, the milli. For most of the units we're going to use, those are the ones that get used commonly. The other ones kind of get forgotten. I've never seen hecto used for anything, or deca. A deciliter for capacity I've seen used in medical testing. And in the U.S., we tend to use the centimeter for length just because we are so hung up on the inch as a unit of length. The centimeter is the closest thing to an inch, so we tend to use the centimeter quite a bit. In other countries, though, millimeter is really more common than the centimeter. The nice thing about the metric system, we said it's going to fix a lot of the issues that we have with the standard system. The big issue with the standard system is the difficulty to convert from one unit to a next. Well, in the metric system, you can see if I move one unit to the right or one unit to the left, all I am doing is multiplying by 10 or dividing by 10, because there's either 10 or 1/10 of that unit in the next unit. When I multiply or divide by 10, all I do is move the decimal point over one spot in one direction. So I can actually use this chart that I set out here to do my conversions with metric units. If I have 0.023 meters and I want to convert that into centimeters, when I look at my chart, I'm going from meters to centimeters, from meters to centimeters. To get from meters to centimeters, I'm going 2 spots to the right on my chart. Each of those spots on the chart is a decimal point. They're a decimal place. So I take the decimal point in my measurement and I move 2 spots to the right. That's 2.3 centimeters. If I have 480 millimeters and I want to go to meters, well, from millimeters to meters, from millimeters to meters, it's 1, 2, 3 spots to the left on the chart. So my decimal point, it's not written here, so it's at the end of the number, has to move 1, 2, 3 spots to the left. That's 0.48 meters out of that 480 millimeters. So the measurement conversions in the metric system, we're just moving the decimal point because all it is multiplying or dividing by 10. As we look at some of the other units in the metric system, we will see the ease of converting from length to capacity and from volume to capacity and capacity to mass, and all those are all linked together. Like I said, it was a thought out and created system. We're uncomfortable with it because we're so used to the standard system, but once you get used to the metric system, it is easier to use. Brings up the question, is the United States ever going to convert to the metric system? Well, back in the late 1980s when I was in middle school, our middle school science teacher was by just pounding on the table. Within 10 years, the United States will be switched over to the metric system. Well, we haven't done it. It's been more than 10 years, closer to 30. England, it used to be, our standard system used to be called the English standard system. Almost 30 years ago, England switched over to the metric system. The United States is the only industrialized country in the world that is not on the metric system. It's going to happen some point. We're slow to do it. A lot of your international companies like IBM and others have actually announced a few years ago, actually more like 5 or 6 years ago for IBM now, that all of their manufacturing, whether it was done in overseas or in the US, is going to be done in metric units. Because then they don't have to do all the calculations in both metric and standard and have separate blueprints for overseas and standard ones for in the US. They figured the first year they did it, they figured they saved almost $8 million by doing everything metric and not converting between the two. So those international companies are making that switch, and it's going to happen. We're going to slowly see it fade out. So now, I want to take a look at what we use some of our measurements for. One thing that we use is perimeter. Perimeter is the distance around an object. And it can be found simply by adding up the length of the sides. If I have a rectangle, and this is 4 inches long, and this here is 13 inches long, well, I can find the other sides because I know that opposite sides of a rectangle have to be equal. So this is 4 inches, this is 13 inches. So my perimeter is simply, I just pick a spot and go around the rectangle. 13 inches plus 4 inches plus 13 inches plus 4 inches, which of course adds up to 34 inches of perimeter. Now we haven't really hit algebra yet, but we could use a little algebra here. That's the length plus the width plus the length plus the width. We could shorten that formula up a little bit to be just 2 times the length plus 2 times the width. is the perimeter of a rectangle. If I put in my length here, P equals 2L would become 2 times 13, 2W would become 2 times 4, and our order of operations works it out. 2 times 13 is 26. I'm going to cheat a little bit here and do 2 steps at once. 2 times 4 is 8, and 26 plus 8 is 34 inches. We get the same perimeter using the formula, or by just adding the sides up, brute force. Let's talk about a circle. Next to rectangles and triangles, a circle is probably the next most common shape in construction. Wood construction, not as much as some other things, but in furniture making, the circle comes up a lot. If we look at a circle, the perimeter of a circle actually has a special name. It's called the circumference. Now, even though it has a special name, it's still okay to refer to it as the perimeter of the circle. It was found, well, right around the 200 BC or so. The diameter of a circle, of course, is the distance across the circle. We'll talk more later on about what the official definition of a diameter is. But they found that there's the ratio of a circumference of a circle divided by the diameter of a circle was always the same number. It came out to be 3.1415926, blah, 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 blah. It kept going on. And now, since they couldn't ever really calculate that out exactly, in fact, we found that you can't, it goes on forever, they assigned a symbol to it. The symbol was the Greek letter pi. That's equivalent to the U.S. letter P. But the pi then was that ratio. Circumference divided by diameter was defined to be pi. Now, we're used to seeing that formula rearranged a little bit to say the circumference is equal to pi times the diameter of the circle, or diameter times pi, however you want to write it. So if I say that this is 16 feet diameter across that circle, the circumference is pi times 16 feet, which comes out to be 50.24 feet. Now I should declare that in this calculation to get 50.24, I am using pi as 3.14 when I do that calculation in my head. Your calculators do have a pi key. If you use the pi key, you might get like 50.26 instead of 50.24. Same number. We're not going to worry about it. On a quiz or a test, you can either use 3.14 for pi, or you can use the pi key. I actually do my answer keys both ways. So I have, the 3.14, and then I have the pi button. So either of those answers or anything in between them is acceptable on a quiz or a test. There is a quiz out there. I believe it's quiz 5 or quiz 6. I don't remember. It is posted out there that is on the measurement, accuracy, precision stuff from the last few days. That is due at noon tomorrow, so noon, September 17th. It is out there in Blackboard for you in the week 4 folder. Our new homework for today is in the little book. It is Unit 19, the odds. Now, since most of you are at home today rather than in the classroom, I'm not going to make you sit on the network and do homework. If you want to, I'll still be logged on here for a while to answer your questions. Otherwise, you are welcome to clean up your spots and head out, and we will see you all tomorrow.